What? I'm way more Canadian. My family's lived in Ottawa for like forever.
Have you even made maple syrup before?
I don't know. Well, I bet you I can stand out in the cold for way longer than you.
Go for it.
Okay. Cold. Do you know what? I know how to settle this. Let's call Clark. Okay? Let's ask him. Hi, Clark.
Hi, Ian.
Who's more Canadian, me or Alex?
I'm way more Canadian.
Well, who's the better skater?
I've never been skating. I can't believe we haven't even been skating before. How can we call ourselves Canadians?
Walk a mile in these Louboutins, but they don't wear these shits where I'm from.
What the?
Oh God. Should we go help them?
Whoa, can we help you guys? I'm very experienced at skating. I skated every day on my trip this summer.
You went on a trip this summer? You never talk about that. Anyway, can we help you?
That would be useful.
Well, the first thing you have to know about skating is the reason you can skate is the low coefficient of friction between your blades and the ice.
Alex, be careful! You might never stop sliding. Newton's first law says that objects in motion won't stop unless acted upon by an external force. Silly Ian, you can't skate like you were running. You need to work perpendicular to the ice because the coefficient of friction between your skate and the ice is so low.
This is a great example of Newton's third law. When you apply force onto the ice with your skate, the ice applies an equal and opposite force, allowing you to push forward. This means that if you increase the force you're pushing with, or increase the angle towards the ground, you'll increase your acceleration.
Alex, come over here. Come see. The coins don't slide that much. Doesn't that mean there's a really high coefficient of friction?
That's because of the thin layer of water that forms underneath your blades. Without the liquid film, the coefficient of friction is about 0.6. But with the film, the coefficient drops below 0.005.
Working on my shit.
There are a few ways the film can form. The first is pressure melting.
Wait. I learned this in AP chemistry. Okay? What happens is when you're skating, the entire mass of your body is exerting force on a very, very small blade, which puts tons of pressure on the ice and causes it to melt, thus reducing the coefficient of friction.
Another is melting by the heat caused by friction. The ice moving melts tiny amounts of water underneath the blade.
Oh, and the coin isn't heavy enough to exert enough pressure to melt the ice, so it has a high coefficient of friction.
Working on my shit.